No, if you could do it all in one video, it would be great. I mean, but you can do it between all the time you need. That's fine. Yeah. Sounds good.
So you just need to go on, like, you finish already, right? So you just need to go on and make it exact.
Yep, so initially we start by measuring the diameter of the wheel of the DaNi robot, which is roughly 10 centimeter. So the circumference of the wheel would be 10 pi centimeter. So, and it's supposed to travel for 200 centimeter in a straight line. So the number of revolutions needed per one side of the square is 200 centimeter divided by 10 pi, because 200 centimeter is the line and 10 pi centimeter is the circumference. That's distance per revolution. So, and the angular velocity we input in the program into the program is 6 radian per second. So we know that it takes 2 pi radians for making a complete 360 degree rotation of the wheel. That's like one revolution. So number of revolutions per second would be 6 radians per second by 2 pi. So finally we calculate the number of seconds to run in a straight line. That does making one wheel turn in the clockwise direction and the other in the anti-clockwise direction for this long. That's the number of revolutions per side divided by the number of revolutions per second. So that would come up to 6,670 milliseconds, and that's what we made use of here. And this sequence here is for the robot to run in the straight line. And again, we measured the distance between the wheels, between the midpoints of the wheels, to be a little over 36 centimeter. And to make a 90-degree turn, it's 1/4 of a circle, that is 36 pi divided by 4 is 9 pi. So 9 pi is the distance that each wheel has to travel to make the turn. So number of revolutions per turn is 9 pi is the 1/4 of a circle divided by 10 pi, which was the circumference as we previously calculated. And the angular velocity is 6 radian per second. That's our input again. And so the number of revolutions per second, again 6 radian per second by 2 pi. And number of seconds to run in a straight line would be 9 by 10 divided by 6 by 2 pi, and that makes it 0.3 pi. That's 942 milliseconds. But to account for sliding of the wheel while making the turn, we had to tweak it up a little bit, and we had to use 970 milliseconds. And we put the whole thing in a while loop by giving the stop condition of the while loop to be false so that it's infinite. And yes, that's about it.